Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is ticket counter, and it is an easy level problem. So since today was a Sunday, I was busy with the lead code weekly contest in the morning. That is why I couldn't upload the video. But anyways, let us quickly discuss this particular problem. So they say there are n people numbered from 1 to n standing in a queue, right? So the way the tickets are distributed is like the first k people are given the ticket and then the last k people are given the ticket, and this process keeps on repeating. Our task is to find the last person to get the ticket, right? So what we essentially have to do is, like for example, this is a queue. I'll explain you this particular thing with the help of an example, but let us also have a look at the expected time complexity. So they say like O of n and is the time complexity, as well as O of n is the space complexity, but there also exists a O of 1 constant time solution. So we'll discuss both of the solutions. Now let us have a look at the sample test case as well, what the problem says. So we have been given two integers n and k, right? So the numbers will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So what happens essentially is that the first three people, because the value of k is 3, so the first three people will be given the ticket, right? Good enough. So these three people are now removed from the queue. Now the last three people will be given the ticket, so these last three people are removed from the queue, right? Now the first three people will again be given the ticket. Now since the person 6 is the last person to get the ticket, that is why 6 will be our answer, right? So this is how we have to solve this particular problem. So a very straightforward approach, like without the need of any second thought, would be to use a DQ. So DQ is an inbuilt STL data structure in C++. So the major advantage of DQ is that with the help of DQ, you can pop elements both from the starting and from the end, right? So you can just directly push all the elements 1, 2, 3, 4, 5, 6, 7, 8, 9 into the DQ. Now you can have some variable, let's say boolean variable p. So it is initially 0. So when p is equals to 0, you will pop elements from the front, right, one by one, right? You will pop it either k times, right? In this case k is 3, so you will pop it either 3 times or till the DQ becomes itself empty, right? So for example, if there are only 2 elements remaining and the value of k is 3, then obviously you cannot pop more than 2 elements, so you will only pop 2 elements, right? So you will pop 3 elements from the beginning, then you will pop 3 elements from the end, then you will again pop 3 elements from the beginning. This is how you can do it, and you will update this flag or p variable every time you pop from one side, right? So if p is 0, you pop from the beginning. If p is 1, you pop from the ending, right? And each time while you are popping, you might have your variable called last or answer variable. Each time while you are popping from the DQ, you will update the value in the answer variable or the last variable, whichever you call it, right? So this is how you can solve it with the help of a DQ. So this was not very difficult, just a simple approach. So let us discuss constant time approach, which you can with which you can solve this particular problem. So let's say the value of k is 4, right? So let me write some numbers here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So I have these numbers with me, right? So the value of n in this case would be 18, right? So I was trying to pop some elements from the beginning and some elements from the end. Now let me just consider these two operations as one atomic operation. So I pop some k elements from the beginning and some k elements from the end. These together will be considered as one atomic operations. So the total number of elements that I pop in one operations will be twice into k, right? In this case it would be 8. So you will see that this is the first operation that I perform. So let's say this is the first operation that I am performing. Now the next operation, 4 more elements from here and 4 more elements from here, right? So if I keep on repeating this process, you will observe that you will always have at max 2k minus 1 elements at the ending, right? So if you have these number of elements remaining at the ending, what you can essentially do is you can divide it into two parts. So either you have the number of elements, let's say number of elements n remaining is between this particular range from 1 to less than equals to k, and it can be from k plus 1 to 2k minus 1, right? So your remaining elements can be either from this range or from this range, right? So once you have removed these elements, the total number of elements removed would be a multiple of 2k, right? So let us assume that after removing these elements, this is the left pointer and this is the right pointer, right? So once you have got the left and right pointers, from this you can find the size. So either you will lie in this particular case, case 1, or you will lie in this particular case, case 2, right? So let's say here the value of k was 4, right? So let us assume the first case. So we are not discussing these values here. Let us just assume some general case. So let's say these are the 3 values remaining and the value of k is 4. This is obviously from case 1. So the left pointer will be here and the right pointer will be here. So when the value of n is less than equals to k, the answer will always be the right pointer, right? So let us discuss different cases. For example, both left and right pointers are at a single element 1. So the answer will be this itself. Now let's say there are 2 elements remaining. Left pointer is here, right pointer is here. So this element will be executed first, and after that this element will be executed. So the answer will be the right pointer again. If there are 3 elements, the left pointer will be here, right pointer will be here. These 2 elements will be given the ticket first and then this particular element. Similarly for 4, 1, 2, 3, 4. This will be given first and then this the second element, then the third element, and at the end this particular element. Right. So you see, whenever the value of remaining elements is less than equals to k, the answer will always be the right pointer. Now let us discuss this particular case. So let's say the value of k is again 4 and we have 5 elements, 1, 2, 3, 4 and 5, right? So now the left pointer is here, right pointer is here. Now in any case, these 4 elements will be executed first, but after it, the elements on the right will get executed first, right? So if there were like 5, 6, 7 elements, then these will be executed first, then this will be executed, then this, and then this, right? So how do you find this particular value? In this case, which I have discussed at the last, this will be the left pointer, this will be the right pointer, and I need to find this particular value. So I can just directly add the value of k to L. So if I add k to L, L will move to here and I can again return my left pointer, which is this particular pointer, right? So because this is only because I will first execute these part and then I will start executing from the right. So this element will be executed at the end. So what if like all the elements are exhausted? Let me discuss this particular part. So if you see, if the value of k is 4 here, so you will form these 4 elements and then you will form these 4 elements, right? Now after this operation is completed, the right pointer will be here and the left pointer will be here. So whenever the number of elements is a direct multiple or is a multiple of 2k, right? Or you can also say that n mod 2k is equal to 0, the answer will always be the left pointer. So this is a special case that you need to take care of, right? So that's the only thing that we had in this particular question. Now let us have a look at the final code. So you see, this is the first approach that I discussed. Let me just show you from my submissions. So this is one of the approaches. You will see that this one is correct and accepted, and you will see that what I have done is I've created a DQ and I've created a boolean flag p, right? So I just push back all the elements into my DQ, and while the size of DQ is non-zero, I'll just check if p is equals to 1. If p is equals to 1, that means I have to pop from the back. So I'll initialize a new variable which is equals to k. So this is small k and this is capital K. And while both of these conditions are satisfied, either dq dot size is greater than 0 or my k value is greater than 0, right? So I'll update my last element as dq dot back and I'll pop back from my dq. Otherwise, if the value of p is 0, I will again set my value of k as capital K and then these two conditions. I'll update my last element as dq dot front and I'll pop my front element. And at the end, if like in either of the cases, in this if else, after I come out from this, I just change the value of my PA variable. So if P is 0, P XOR 1 will be 1. If P is 1, P XOR 1 will be 0, right? So at the end, I can just return my last variable. So last is the last updated value, right? This is the first approach. Now coming to the second approach, what I've done is I've calculated the total number of times I can perform the unit operation. So the unit operation I talked about was removing k elements from the beginning and removing k elements from the end. So in total, I will have to remove 2k elements, right? So this is the number of times I can perform that operation. So this will be equals to n divided by 2k, right? Now what I can do is I can find the value of left and the right pointers. So cut is the number of times I remove from the front and cut is the number of times I remove from the back, right? So the left pointer will be at 1 plus cut into k and the right pointer will be at n minus cut into k. Now if right is less than left, so this is the case when 2k
is a divisor of n, or n is a multiple of 2k, right? So this will be that case. In that case, I can just directly return left. This is the last case that I discussed. Now otherwise, if the size of the remaining elements is less than equals to k, I can return the right pointer. Otherwise, I will increment my left pointer by k and then return my left pointer, right? So this was all about today's problem of the day, and I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, as your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach more number of people like you who want to keep solving new problems. So subscribe to this channel, as I see a lot of people who watch these videos have not subscribed yet. So in case you haven't, then consider subscribing and share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.